This problem continues problem 4 from chapter 3, which had asked how much would you have after 25 years if you invested $10,000 at a 7.5% rate. Remember, these values are different from the values you actually see in your problem. And the answer was $60,983.40. The first part of the question assumed that our interest was compounded only once a year. So every year, at the end of the year, we received 7.5% on whatever our balance was to date. They want you to revisit the problem and assume that rather than having your interest being paid once a year, it's paid once every 6 months. So what you would do to your rate, in this particular case, if we're to use the equation, we would take that rate and we would divide it by 2 because it's being paid twice a year. And then we would take the number of years and we would multiply those by 2 because, again, there are 2 6-month time periods in a year. So rather than getting paid interest of 7.5% annually, we are getting 7.5% divided by 2, which is 3.75% or 0.0375. We're getting that rate every 6 months. So take 1 plus that rate of 3.75% or 0.0375 to get 1.0375. Raise it to n of 25 times 2, so there are 50 6-month time periods in 25 years. So raise that to the power of 50, and I'm just going to finish this equation so it looks a little better. And then we would take our present value, which is $10,000, and multiply it by 1 plus I, but this time the I is the semi-annual I, to the power of time, but this time time is the number of 6-month time periods there are in 25 years. So using my financial calculator, each time I access this calculator I have to open a new one, but I will take the $10,000 times 1 plus my rate of 0.0375 raised to the power of time, which is 50, and so it's $63,010. So $63,010. I'm just going to round a bit. So you can see that if your compounding frequency is more often than once a year, and I'm earning the same annual rate, so receiving interest once a year for 25 years gets me a value of $60,983, but receiving interest twice a year for 50 6-month time periods, which is still 25 years, but I'm getting paid interest every 6 months instead of interest once a year, lets me earn a bit more interest, about $2,000 more in interest. And so question part 3 of that question asks how much extra would the additional compounding frequency allow you to earn. So you'd take the difference between this value and this value to find the answer. Now we can do this on a financial calculator. So again, I'm going back to the time value of money calculator in the PearsonMyLab website. I would input the same present value. Now here I can change from annual to semi-annual. I personally don't like to do it that way. What I would rather do is just convert my rate to a semi-annual rate in this case. So take my annual rate of 7.5% and divide it by 2. So I would enter the semi-annual rate, and then rather than entering my periods of 25, I would take the 25 and multiply it by 2 to get 50, because there are 50 6-month time periods in a year. And again, I would solve for future value, and there's the $63,010 that I got earlier. And I just want to point out that whenever you input a positive value and you solve for some other value, you'll get a negative answer in return. So if you input a positive cash flow and solve for another cash flow, it'll give you a cash flow of the opposite sign. Most of the time that is not important. You can just omit the negative sign and everything will be fine, although that's not always true. And I will work some examples where it's not true, where you do have to pay attention to the sign in a little bit, and post a new video.